Thank you so much. I really wish today that I could be with you down there, but unfortunately, my schedule through September is prohibiting any travel. But really delighted to be here, and I do want to present IP400. This presentation, just to be clear, is relatively basic. We're not going to get down into the weeds, but we're going to get that good overview of what's going on, where we've come from, and how we're moving forward. It is a project of the Alberta Digital Radio Communications Society. And we're going to talk a little bit about that society before we dive into the project features and goals, what IP400 is and what it is not. And then we're going to go through some examples. We're going to talk about the project aspects and then cover the work in progress. I've also got for you at the end further information with a lot of links that can lead you through to a lot more detail about our project. But let's dive into who we are. Our society was formed in 2022. Basically, we do want to promote digital communications, and we want to develop and deploy networks. We had deployed already the Arden network. And this we did in 2018. We started this, and we deployed it in Alberta, grew it into BC, Manitoba, a lot through northern Manitoba because we were the closest Arden node, and up into the Northwest Territories, specifically the capital of the Northwest Territories, Yellowknife. We needed to ensure that we had a succession plan in case our main person got hit by a bus or something. So we decided that the best way to do that was to create a Alberta society and put all the assets into that society. So with that network having been deployed in 2018 and growing steady through 2019, 2020, right through to this year, 2025, we did manage to enhance that network with enterprise grade servers, which were donated to us. We diverted them actually from an e-waste situation and managed to bring them into our rack. We developed a lot of different applications, deployed a secure email server that runs across this. Did a lot of work with Internet of Things devices, and most important, the Alberta Digital Radio Communications Society launched the IP400 project. The basic project goals here, we see that IP400 for us rose out of a number of trends going on. We see that in amateur radio today, there is a new type of amateur radio operator coming into the hobby. Now, clearly, as I listened to previous presentations today and heard the questions, most people here, I mean, it's obvious you follow zero retries, so chances are you're more data centric, you're more digital, but the general amateur radio operator, specifically here in Canada, is not. We are seeing our spectrum, both VHF, UHF. If you listen to repeaters, there's nothing but silence. So if we can't start to populate more traffic across our repeaters, it's the old case of use it or you're going to lose it. And we also see that there are more people interested in data modes. It's interesting that in Canada, when I looked at all the various amateur clubs that I have belonged to, they're decreasing in size, in members almost every year. Yet, according to the data out of Industry Canada, the number of amateur radio licenses issued each year is growing at a rate faster than the population. So those typically aren't joining clubs and doing stuff. So we really feel that we can, by offering more digital services, get more people involved in amateur radio and join clubs. And, as the Vulcans would say, live long and prosper. So the goal of our project really is to develop that next generation of data communication systems for amateur radio by amateur radio. We want to see higher speeds, more robust modulations. And when I talk about data, I like to see error correction. So we've got to have forward error correction and the ability to transport a wide variety of data types. So that is the goal of the project. So when we look at rolling out some of these features, um, we're looking at higher speeds. We're implementing here a mesh network. And I'll talk more about mesh later on. But we also want to pass any kind of data packet. And we want our protocol not to be burdensome. We want lightweight. So we don't need a lot of overhead in this. Our phase rollout plan, it was very, very basic. In the early phases, we used just off-the-shelf, commercially available, inexpensive stuff. We need to develop a proof of concept and get things ready for later volume production. And we are also looking at introducing a high-speed modem, and that modem is going to operate in the 400 or perhaps the 900 megahertz band using OFDM. Initially, we're looking at speeds here about 1 meg, and our best dream here is to hit 40 meg in the future. In terms of what IP400 is and what it is not, it is higher speed data mode in minimum of the 400 megahertz band. We are using off-the-shelf components, and we are viewing this as digital DNA for the next generation of data networks. It's a data transport for modern day data streams. And as you can see here, we talk about digitized voice, MMDVM modes. We're talking about position location data and telemetry. We want to build out a local mesh network with dynamic routing information, and it can be either fixed or mobile. And the IP here stands for intelligent protocol. And we also want to be very clear what it is not. At present, operating below 400 megahertz is not going to give us the speed we need. We will lack the bandwidth. And at present, there's not a single chip we can use in the project. IP400 also is not an SDR project. It's not interoperable with our Arden network. And it's not just another implementation of a packet network like AX25. I want to talk about the three aspects of the project, and we'll go into this in some detail momentarily. But we view those three aspects of this project as transceiver development, user interface development, and then application deployment. When it comes to transceiver development, we have a bit of a roadmap that we have been following. And if we look at the first two phases, phase 1 and 2, they are already released. But in phase 1, this is where we just used off-the-shelf, commercially available, inexpensive stuff, got it out the door, proof of concept. We did phase 2. And in phase 2, we made a couple changes. We repackaged things, smaller form factor, and we also layered on a Pi hat. And we got the power to 100 milliwatts. And those two phases are complete and done. Phase 3 is basically our introducing a high-speed modem. And in phase 4 on this roadmap, well, we're not really sure where that's going to go. That's to be determined, but that is where we're definitely looking at some far, far higher speeds. When we look at the phase 1 hardware, I already commented that it was really off-the-shelf stuff. And we got a module from ST Microelectronics. This really just allowed us to do nothing more than a proof of concept and develop some software. Our power output was quite limited. And when you unbox this, you basically got the module, the antenna, some basic firmware. And through a beaconing, you could actually discover the mesh. And you can get higher speed data interface using an attached Raspberry Pi. The user interface on this was basically just a very basic terminal emulator on the Pi, just a menu-driven UART. And online, when we sent this out to the evaluators, there was step-by-step instructions online. Phase two got just a little more interesting because in phase two, we started to repackage it. The integrated Pi Zero and the Mini Node 1 hat module got the power up a little bit. And so when you unbox this, you got a little more stuff. You got the assembled and programmed Pi hat, standoff kit, the antenna, and the Pi Zero if you ordered it. Again, instructions are all online, and we're running here the same firmware as we did in the first phase. So everything is backward compatible here. And to date, 75 units built, and they have all been shipped. So where does this leave us? Before we go on to anything else, we need to change that node a little bit. So this is something probably never seen before. And this is the Mini Node 2. It's in a new form factor. And it's still compatible with all the previous ones, powered USB only, and we will begin producing these in October of 2025. The power output will be limited to 100 milliwatts. One thing I do want to comment on, we are having to make some significant changes in our supply chain so that we can ship these to the US. Because as of about 2 weeks ago, we can no longer ship into the US. So our supply chain will change, and these should be available for shipment into the US or available through a US distributor. So this is absolutely brand new. So this required a fair bit of redesign on our part, but we're really pleased with the new form factor. In fact, we're also announcing today the next piece of hardware, which is an outdoor node, and it has the same mini node here in the board stack. It has a 5-watt power amp and an antenna. And this illustrates a number of things to me. One is the collaboration we have within the amateur community. The power amp comes to us via the M17 project, and the antenna comes to us via K5 FRC, which is the Fannin County Amateur Radio Club in Texas. And with their permission, we'll be including this with the outdoor node. Supplied by the user will be the PVC tubing. And when we look at this, with the gain we get from the power amp and the antenna, we're looking at putting out not a bad little bit of power for outdoor. So that is something I guess no one's really seen before. We talked about user interfaces earlier. We've got both human interface as well as machine to machine. Today, it's just a UART on a Pi, accessed with a terminal emulator. Our machine to machine interface is there today as well. What's upcoming is the more sophisticated user interface, which is in development, that's web-based. And that looks a little bit like this as a block diagram. So an HTML server, database manager, and a Java interface that brings stuff together. So this is under development now, and this will roll out likely over the next 3 to 6 months. When we look at applications for IP400, we do view this as a next generation packet network. So our mini nodes right now can achieve about 100K, optionally maybe up to 600, depending on where you are. And we also look at this for digital repeater linking. And this is something that is near and dear to my heart because I'll share a story momentarily with you about an amateur radio in a club in Alberta that links the repeaters and had an issue actually almost about a year ago. So we're looking at doing digital repeater linking and supporting both analog and digital and transcoding between modes. And that's really through the MMDVM project. So here's conventional repeater linking, just to show you what um, is really quite common up here in Alberta. And there's a single point of failure, which is the linking hub. So with this is just showing some basic 4 repeaters through a linking hub that basically can broadcast over a wider area. The single point of failure is a problem. And up here in Alberta last year, a linking hub for one of the amateur radio clubs caught fire. The building caught fire, burned to the ground. And that really put a bit of a kink into their linking. So, and as of today, they're still not linked. They haven't been able to get that rebuilt. With IP400, you build a mesh network. And if any node goes down, you still have multiple paths to get to it. So from an analog repeater perspective, the end user in this case really does not see any real changes. It's still business as usual. What we want to see in the future with IP400 is a lot more than just the status quo. We are really here looking at supporting data modes, servers on the network, supporting an MMDVM transcoder, um, still doing analog across it. You can still do that. And also implementing what we're calling a super node, or I believe, Steve, you called that a super Peter at one point. And really what that's going to allow is the integration of even mobile data through a TNC. So we're really trying to bring everything together into a single network. If you're just an analog amateur radio guy, nothing changes. If you're more data centric, you've got everything you'd ever want through the network. I mentioned the super node, and here's a block diagram of how this is going to roll out. And there is going to be a comprehensive project plan drawn up on this in the next few weeks. So there'll be more we can talk about this, but that's basically the block diagram of how we view the super node. So the hardware work that we have in progress today is the mini node 2 that we saw earlier is in prototype phase right now, and we will have that ready to ship continent-wide by Q4 2025. So we're very close to having that go out in the next, I would think, 60 to 90 days. The outdoor node, we're in the midst of evaluating that power amp from the M17 folks. And we've got to do a bit of a new layout, but we should have that out also probably end of Q4 this year. So we're really looking forward to that. The super node, we have a development scheduled to start. I think it actually started. Project plans are being developed right now. So we'll have most of that development starting in Q4. And that's where we intend on supporting all of the digital modes through the MMDVM TNC. And the high-speed modem, the high-speed modem, we say development to follow the super node, but we're already drawing up the project plan for that with an initial target of 2.5 meg. And what we are looking for now is development help. So we are actively pursuing uh, people that have experience in OFDM and FPGA and all those fancy four-letter words. So if you or anyone else is interested, we would absolutely love, love to have you on board for that. We got some software work we're doing. So with the Mini Node 2, other than support for the external PA, no new features planned. The Super Node, we got some code to write. For the high-speed data modem, we've got a fair bit of work to do. And I think this project plan should be completed within the next few months, and then we actually begin the hard part. The HTML user interface, the enhanced user interface, we're still working on that. Part of that is done, more development to do. And again, there's just a lot more layer 3 development that we're looking at doing. And once again, with this project and the amount of things that we have to do to get this completed, we are looking to augment all of those that have already shown interest in helping. So again, if you know of anyone or if you yourself are interested, we would very much like to have you come on board. The information on the project can be found in a variety of places. The Alberta Digital Radio Communication Society website has some information and directs you to a IP400 project site. All the source code is on GitHub, and we have two group chat sites on Groups.io. One is just a general group, and then the other one is the developer chat site. So again, if you're interested in working on the development of this, for access to that site and to show interest, I'd encourage you to speak or email Martin, that's VE6VH at adrcs.org. And like I say, he is actively looking to build out the team to get this project delivered. So today we've gone through who we are, project features, what it is, what it isn't, talked about the project aspects, talked about the timelines, what's in progress, and the fact that we really do need more people to work on the project. So again, if there's interest or if you know someone who you think would be interested in dipping their toe in this water, we would be delighted, absolutely delighted to hear from you. So with that, Steve, are there any questions?
Not currently any questions.
I will add one thing, by the way, Steve. The previous speaker was from ADRC. And chances are, if I was there, I'd go up and give him a big hug because as a result of their grant, we have the ability to develop that high-speed modem. So we were absolutely thrilled to be able to do that with the help of ADRC.
Hi, I'm Skylar, Director of Technology at Amateur
Hey.
Radio Digital Communications, and I just want to say the hug would be gratefully returned. IP400 is exactly the kind of work that ARDC exists to support, and so what you're doing, please keep it up.
You cut out there, but thank you very much.
Speaker gift for you that we will be mailing up to you, and thank you for being able to do this and sharing about IP400. Steve, any questions you have?
Yes. Is the prototype stage going to continue, or is the amount of hardware that you've shipped to date all there's going to be until the phase 2?
Yeah, that's going to be it, Steve. The Mini Node 2 in the new form factor should start rolling out shortly. The big issue is getting that product into the US. So we're dealing with a supply chain now that is compliant with the US, Canada, Mexico Free Trade Agreement. And that should make everything work very, very, very well. Um, yeah, because that has been a headache over the last 2 weeks.
One last question from the online audience. What modulation scheme was used on the first two prototypes?
Great question. And for that, I would have to refer that gentleman to Martin. But Steve, I will get back to you on that. And if you could forward it to him.
Good enough. Thank you.
Good. And I'm really pleased that my voice held up because I lost my voice last night. So
Thanks again.